Hi, let's continue our discussion on implementing decision tree. By the end of this video, you will be able to expose the overfitting issue in decision trees. Now in the previous video, we built a decision tree classifier that was overfitting. So we asked you two questions. Why the decision tree classifier ended up overfitting, and why did this not happen when we implemented the linear models? The answer is that the linear model we built before were the parametric models and therefore has a finite and fixed set of parameters to learn. On the other hand, a decision tree is a non-parametric model and therefore keeps on learning from the data unless there is nothing left to learn. A good way to observe this is to see how our decision tree grew over the training data. To visualize the tree, we will need to install a library called GraphViz. We can do this by simply using the pip command in the Jupyter notebook itself as shown on the screen. Note that you will require an internet connection to download and install this library. To visualize the decision tree, we first need to generate the tree structure using the classifier instance we created before. For this, we will import export_graphviz function from the sklearn.tree. What this function does is that it creates an intermediary file which contains information about the nodes and edges of any tree graph like diagrams. So we will call export_graphviz function and pass some parameters to it. The first parameter is decision tree. Here we have to pass the decision tree model which we have built. The second one is out_file. Here we have to specify the name of the output file. We will name it as tree_viz. The third parameter is max_depth. We have specified none here, which means that the full tree will be drawn. Next is feature_names. Here we have to specify the names of the features we provided to the model. We would recommend you to read the official documentation for a more detailed description and the link to which is given in the helper text below. Once we run this cell, there will be an intermediate file generated in your working repository. Now we have to use this intermediary file to render an image of the decision tree we built using the GraphViz library. For this, we will import the render function from the GraphViz library and pass three parameters, that is file path, format and engine. File path represents the intermediary file which we generated just a while ago, so we mention tree_viz here. Format represents the output format. We will be using the PNG format. Lastly, engine represents the rendering engine which we won't be discussing as it is out of scope of this training. Running this cell will take time, so get yourself a cup of coffee. Once it finishes running, an image of the decision tree will be generated in your working folder. Let's open it and see how it looks. This is a very big tree. Visualizing this at whole is a difficult task. So let's zoom into the region we have marked in red. On zooming, we can clearly see that every terminal node only contains very few observations as represented by the red dots, which means the decision tree kept splitting the nodes until there was no impurity left in it to split. This image verifies what we discussed earlier, that decision tree tries to learn each and every point in the dataset, resulting in an overfitting model. For example, if a decision tree had as many leaf nodes as the total number of data points in the dataset, that means each leaf node has only one data point in it and not a collection of homogeneous data points, which was the original objective of the tree. So how can we prevent a decision tree from overfitting and learning too well from the training data? Well, that is a question for the next talk. See you there.